In this video, we're going to talk about how to deal with cases where we have a line and a circle, but these two functions don't have a point of intersection. So this is the third and final scenario of our three different cases dealing with types of points of intersection between lines and circles. So essentially, what we have here is we have, I'm going to use an example again, right? So we have x minus 2 squared plus y squared is equal to 2. And then we have a line in this case. The line follows the equation 2y plus x is equal to 6, right? Now, remember the first step when it comes to points of intersection, whether it's a tangent or it crosses at two distinct points or it has no solution, we need to combine the function for the circle and the function for the line, because we're saying that for a point of intersection, it has this, the line and the circle have the exact same x at that point and the exact same y. That's why they're intersecting. They're meeting at that point, which means they have the same x values, y values. So that means we can actually mix these two formulas, right? We can take this equation and then mix them in because we can basically solve for them simultaneously because they share the same x's and the same y's. So what we're going to do is we're going to take this second one and we're going to turn this into, we're going to take this 2y, take it to that side so that our equation becomes x is equal to 6 minus 2y, right? Now, after this, then we can take this and substitute this x term into that x expression over there. So that means our first equation, instead of being x minus 2, your x is replaced by this expression. So it becomes 6 minus 2y. Remember, that's your x. And then we have minus 2, right? So that's squared plus y squared. This is for the last couple of examples, we substituted y in our expression. I just also want to show you that we can substitute x and we can get the same answer. It's this exact same approach, right? So then from this point, we simplify, right? So we have 6 minus 2 in that bracket, which becomes negative 4. So that bracket becomes negative, oh, sorry, it's positive 4. It's 4, let me just do this. 6 minus 2 is 4. And then we still have plus 2y plus y squared is equal to 2. And then we have, so this is supposed to be squared. So now we can square that bracket. So in order for us to square, we say, okay, 4 squared, that becomes 16. 4 times negative 2y becomes negative 8y. You multiply that by 2 to get negative 16y. And then over here we have 2y squared, or at least negative 2y squared becomes positive 4y squared. And then plus y squared, that's equal to 2. Okay, next thing we do is we simplify our expressions. So we're going to start off with the y squared expression. So this one and this one, you add those two and they become 5y squared. Our next one is going to be the y expressions. We only have one of those, that's negative 16. So we're going to write that over there. And then we also have, so these are gone, these are done, these are done. We're going to take the 2 and it becomes that side. So it becomes negative when it crosses over. So now you have 16 minus 2, which gives you positive 14. That's equal to 0. All right. So this was actually supposed to be 16y. So this is our resulting expression, right? And like we said in previous videos, when you're working out the point of intersection between a circle and a line, the resulting equation from that simultaneous equation is going to be a quadratic expression. And we know that quadratic expressions have an a value, which in this case is positive 5, a b value, which in this case is negative 16, and a c value, which is positive 14, right? And we're going to use these to solve for y is equal to negative b. So this is just going to be the quadratic formula, plus minus the square root of b squared minus 4ac. If you've been watching previous videos, this is kind of repetitive, right? But hopefully we're kind of hammering home, all these different things for determinants and all of that stuff. So it becomes easier once we get to exam papers. Okay, so for us to solve y, then say, okay, y is equal to negative b is negative, your b is negative 16. So it's negative 16, right? And then you have plus minus the square root of your b squared is negative 16 squared minus 4 times your a value, which is 5, times your c value, which is 14. All right, that's all over 2 times a value is 5. Okay, so let's simplify this. This is y is equal to positive 16, because negative and a negative gives you a positive, plus minus the square root of. So I'm going to take this expression and put it into my calculator, right? So we have 16 squared minus 4 times 5 times 14, which gives us negative 24 square root, divided by 2 times 5 gives you 10. Now, the thing is, the problem with this is, even though we're saying, because in previous videos we say, okay, in order for us to solve this, we say 16 plus, so you solve for this when that plus minus plus first, and then you solve for it when it's negative, right? But even if, so let's just say, for example, you try 16 plus square root of negative 24 divided by 10. This is going to give you an error. The reason why it gives you an error is because this is not a real value, right? The square root of a negative is not a real value. It's complex numbers, right? That's nonsense that you only have to deal with in your A-level stuff, right? For now, we say this has no solution. So this tells us, so whether it's positive or negative, because our equation has this root of a negative, it's going to mean that y cannot give you solutions. So y has no solutions. And what does that tell us when it comes to our the thing that we're trying to solve? It tells, because remember, your y that you're trying to calculate is the point of intersection. So if there's no solution, that means there's no point of intersection. So that means whenever your root over here, the thing that's in here, has a negative, it means you have no solution. We call this expression, this is your b squared minus 4ac, right? We call this the determinant. And we denote it with this little triangle sign over here. So if your determinant is less than 0, then you have no solutions. Or we can say that you have no points of intersection in this case. No points of intersection. My handwriting is turning into a horror show, but hopefully, because I'm dictating it, hopefully it makes sense. But essentially, once you combine these two expressions, once you combine your circle function and your line function, and the resultant quadratic has a determinant that's less than 0, it means that you have no solution. Whether you're solving based on y or x, is the exact same thing. Because you can't solve for that, there is no y based on that equation, and there is no x based on that equation, it means there is no point of intersection. So essentially, that is the conclusion in this case. So it means that we had determinant, when your determinant was positive, we had two distinct solutions, or 2 points of intersection, right? Which means you have a circle there, and then a point of intersection that looks like this, right? We had the second one where your determinant was equal to 0. This gave us one solution. And this means that you have a circle over there, right? It only meets once, right? So which means it's a tangent. It looks something like this. Or we have the case where your determinant is less than 0, right? In this case, that means you have no solutions. That means if your circle looks like this, maybe your line looks something like this. They don't meet. So these are the 3 different types of solutions you get, and it's all based on that little thing, that expression that's inside your square root. Now, just like we did for our tangent graph, which is this, but let's just mute this a little bit. I've gone ahead and gone back to Desmos, right? Which the website is here. You can just type in desmos.com and go to the graphical calculator. But I've drawn the line. We still have the circle that we used before. It's a circle that I'm using for all the examples. And then we have a graph that we have proven that has no solution. But then just to look at it graphically, we can see that there is no point of intersection between the line and the graph. In the first example, for 2 solutions, we use the equation y is equal to x minus 2. So we can see this one clearly has 2 distinct points of intersection. And then we also have the one where it's a tangent. So these were the different scenarios for our circle, where we have one solution over here, one line that just crosses through at two distinct points, and a line that does not cross at all. So all of that is based on the determinant. So it's very important for you to grasp your head around determinant stuff, whether it's for quadratics, it's for circles, in coordinate geometry, whatever it is. But the determinant is a very important concept in maths, fortunately or unfortunately. But yeah, hopefully this all makes sense. And in the next videos, I think I'm going to have two videos where I just have a couple of examples where it's not going to be as straightforward as the ones that we just looked at. Maybe in those cases, it's going to be a little bit closer than what you're going to get in your exams. With unknown values, they'll tell you that, okay, this has a tangent, then calculate for the unknown and all of that stuff. So we're going to go through those examples, and then from that point, we will be done finally with coordinate geometry. So hope I see you there, and I hope this video was helpful.